Hello friends, in this video I'd like to solve the following problem from the Czech-Slovak Match 1999, problem number 5. We want to find all functions f from the interval 1 plus infinity, open on both sides, into the set of real numbers, satisfying f of x minus f of y equals y minus x times f of xy for all xy greater than 1. So here are my hints for this problem. It's all about setting these three pairs of variables. First, set x and y to be t2, then t4, and finally 2t2. So we will have the system of three equations with three unknowns, and you should be able to find f of t. And from there, you are almost done, but at some point you may wish to set t to be equal 5 over 2 to find the connection between f of 2 and f of 4. And finally, by then you should have the general formula of our function for t with exception of these three numbers, and consider separately what happens at these variables, at these values. So give this problem a try. Alright, so as I suggested, let's make the following setting. First, set x to be t, and y to be 4, or 2 rather. Then let's set x to be t, y to be 4, and finally set x to be 2 times t and y to be 2. We will have the following equations. First, f of t minus f of 2 equals 2 minus t times f of 2 times t. F of t minus f of 4 equals 4 minus t f of 4 times t. And finally, f of 2 times t minus f of 2 equals 2 minus 2 times t times f of 4t. Right. From this first equation, we can derive the value of f of 2t. F of 2t equals, well, f of t minus f of 2 over 2 minus t. And from the next equation, we can find the value of f of 4 times t. F of 4 times t equals f of t minus f of 4 over 4 minus t. Of course, t cannot be equal 2, cannot be equal 4. So for t not equal 2 and t non-equal 4, we have the following. The third equation can be written in the following way. Instead of f of 2t, we can put f of t minus f of 2 over 2 minus t minus f of 2 equals 2 minus 2 times t, and instead of f of 4 times t, we have f of t minus f of 4 over 4 minus t. Alright, now let's get rid of the denominators. We'll have the following. F of t minus f of 2, 4 minus t minus f of 2, 2 minus t, 4 minus t equals, and here we'll have f of t minus f of 4, 2 minus 2 times t, 2 minus t. And now a bunch of algebraic manipulations. I will skip the details. The details are left to you. You will get the following after some simplifications. You will get the following equation. 2t squared minus 6 times t plus 4 times f of 4. Let's write it in this color. F of 4 minus t squared minus 7t plus 12 times f of 2 equals 2t squared minus 5 times t times f of t. Alright, so we are almost there, but now to get f of t we should divide by this parenthesis, but here's problem. This parenthesis is 0 if t equals 5 over 2. So first let's call this condition triangle, and let's set t to be equal 5 over 2 in our condition triangle. We will have the following: 2 times 25 over 4 minus 6 times 5 over 2 plus 4 times f of 4. Well, actually should be equal 25 over 4 minus 7 5 over 2 plus 12 times f of 2, because the right hand side disappears. And from there, after some simplifications, again, the details are left to you, you will have that 2 times f of 4 equals 2 times f of 4 equals actually f of 2. Great. And now let's use this result and let's set it back into our condition triangle. So triangle becomes, well, notice that here we have 2 times f of 4. Here we can factor out basically. Maybe I will write it. T squared minus 3 times t plus 2 times 2 times f of 4 minus t squared minus 7t plus 12 times f of 2. That actually equals 2t squared minus 5t f of t. Right? And now after using this fact, the left-hand side can be simplified greatly. We can actually get the following. After some simplifications, you can get the following. On the left-hand side, we will have 2 times 2t minus 5 f of 4 equals 2t minus 5 f of t, which is great because assuming that t is not equal 5 over 2, we can do the division and we will have the following result: f of t equals 2 times f of 4 over t. And that holds, remember, t cannot be equal 2, t cannot be equal 4, and cannot be equal 5 over 2, because that would be division by 0. So maybe let's put quantifier. For every positive number t not equal to 2, 5 over 2, and 4, we have the following result. So we are almost done. Sorry, I have made a small mistake, sorry about that. Not f of 4, but actually 2 times f of 4 was replaced by f of 2. Sorry about that. Now it's right. Okay. Now, what happens at these 3 particular values? Well, notice that if t equals 2, then obviously f of t equals f of 2, and it's exactly the same as this. So this also holds for t equals 2. Well, if t equals 4, f of t equals f of 4, but f of 4, remember, 2 times f of 4 is f of 2. So it's 1/2 f of 2, and 1/2 f of 2 can be written as 2f of 2 over 4. So this formula also holds for t equals 4. And finally, what happens at 5 over 2? Well, to see what happens, let's go back to our condition, to our very first equation, namely to this one. Maybe I will call it, I don't know, square. This condition square, if I plug in, because it is true for every t, there is no assumption of this equation. If I plug in t equals 5 over 2 in this equation, we'll get the following. So set t equals 5 over 2 in our equation square, you will have the following. F of 5 over 2 minus f of 2 equals 2 minus 5 over 2 f of the product of this. So it's 5 over 2 times 2. Now let's take a look. F of 5 over 2 equals, well, here we have f of 5. So it's f of 2 minus 1/2 f of 5. But f of 5, we can use this formula because it holds for t equals 5. So we'll have f of 2 minus 1/2, 2 times f of 2 over 5, and which happens to be 4 f of 2 over 5. And notice that the very same thing can be written in a slightly different way. Namely 2 times f of 2 over 5 over 2. So we see that indeed this formula also holds for t equals 5 over 2. So we have established that indeed for every t greater than 1, there was another small mistake because we are dealing with t greater than 1. So for every t greater than 1, f of t equals 2 f of 2 over t. All right, so in other words, f of x, we can go back to x variable, f of x equals some constant over x, where a is any real constant. And let's do finally the verification. Verification is very quick. Verification is very quick. On the left hand side, we have f of x minus f of y, which is a over x minus a over y, which is, we can write it as a y minus x, 1 over xy, and maybe let's put a right here. A over xy, well, it's f of xy, which is on the right hand side. Of our equation. So indeed our equation is satisfied. So our solution set consists of functions of the form a over x, where a is arbitrary integer and of course x is greater than 1. And that closes our problem. Thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.